Hey, everybody. We are going to do just an update on what's going on. Today is April 7th. Test 2 should be turned in today. A lot of you have turned it in, but a few have not, and I need you guys to do it. The plan is get it turned in, and then I'll grade it tomorrow. And then the test 2 scores will be released on Canvas. I believe I've posted your test 1 scores on Canvas. As of right now, the cumulative score means nothing because I haven't programmed it correctly. So let's just say total score instead of substitute for cumulative. The total score means nothing until I say it does, so don't worry about that. Today we will have new material. Thursday we will have new material. And in fact, the 14th, 16th, 21, and 23. 23rd will be review. There will be new material on the 14th, as well as today, the 9th, the 16th, the 21st. 23rd is a review. Probably the 21st will also have a lot of review. The 24th, test 3 released. And then comes the interesting part. The 28th, test 3 is due. We will be going over review for the final. The 30th will be more review. And what I'm planning on doing is, since this is all online and we're just trying to live, May 1st, which is that Friday, the final will be released. And the goal will be that everything will be due on, I would prefer May 5th. Most likely what will happen is you guys will turn it in at the 7th. So let's just make it due the 7th. It will be due at noon. And the 7th at noon is kind of a hard deadline. Why? Because on the 8th, grades are due. I have to submit them. So I need you guys to have this turned in by the 7th. If I can get everybody to turn it in by the 5th, that just allows me to post grades earlier. So I'm counting on all of you to come together and get this one thing done, preferably early. But the 7th is going to be a hard deadline. After 7 at noon, if you've not submitted it, I'm sorry. We can talk about it. Maybe as an incomplete. I'll have to talk about that to some other people. People that are higher up the food chain. Let's see. Now, for the 7th, 14th, 21, and 28th, since this is all online, lab worksheets will be handed out. Most likely I'll just turn them in by Thursday. And they will be due for all the 4 weeks. So you'll get a worksheet on the 30th. Probably turn it in by Monday. But the thing that, or actually, this is what I'm going to do. The worksheets for the lab will come out on those days. On the week of the 28th, there'll be a worksheet handed out on the 28th, and then the worksheet will be due on the 30th. Because what I'm planning on doing is that these worksheets will be released. I will give solutions to them will be handed out on the 30th, or posted, or whatever they call it these days. So that's the battle plan. That's the mess that we've got. Just as an announcement for you guys, just in terms of other classes, since in the summer, so for the months of June and July, I'll be doing Physical Science 1, which will be Monday, Wednesday evenings. I have not heard, I know that Ole Miss is having all online for the summer. In fact, the intersessions are online. Everything through the August intersession. But for us, we don't know yet. They haven't made the official announcement. I need 10 people. There's one enrolled in the class right now. I need 9 more for the class for certain. That's the minimum threshold as of right now. I'm going to try to get it lowered. So if we have 5 people and it's all online, I don't understand what the big deal is about having this 10 student requirement. But we're going to try to get as many people as we can. If you know of anybody who needs Physical Science 1 over the summer, I mean, none of us are doing anything for the most part. Let them know about my class. Ole Miss, Northwest, Lafayette High, Oxford High, all of these classes, or this class can satisfy a lot of requirements. For the fall, I'm doing Physical Science 1, Physical Science 2. Physical Science 2 will be Tuesday, Thursday only. Same as Physical Science 1, but also we have a Wednesday night section. Also, there is an intro algebra section that meets Monday nights, and I'll be teaching those. So if you hear anybody who needs those classes, I'm here. Most likely these will be done in person. I have not heard officially about these guys. But if it's online, it's online. And actually, I'll be way more prepared for that than what we're doing now. Now, the material. So for test 3, if you noticed, there was no material on, I think there was no material on fluids, but we'll cover, some of that will be carried over. There's going to be tests on the Greek alphabet. More of those letters. Also, the big test will be, or this test 3 will be, I'll let you guys know during the review, but there's a possibility that I could put this on Canvas and let Canvas grade it, and then the scores will come out far sooner. The other thing that we'll be covering is sound. And why is this not? That be quiet. We'll be covering sound for the next 2 weeks, and then I think that'll be it. That's all we got. So in terms of sound, sound is a wave. And we're familiar with you see something like this, and this is like a rope being, I don't know, agitated. Just sit there and kind of, if you sit there and you and your friend take a jump rope and you just move it up and down. What you see there are peaks and there are troughs. And what this is that this is a vertical translation wave. Where the wave just simply, like a bit of rope, the rope is not moving from side to side. The rope is moving vertically up and down. So this part here, that part there, as well as all the others, that's the vertical motion. So I've said that sound is a wave, but it's not like this. That's like a vertical wave. Sound is energy compressing and rarefying. Not sure if that spelling is correct, but no one cares about spelling. You won't be graded on it in this class. And it's compressing and rarefying air. So when you say things, when I say things, sound is coming out of my mouth, hitting the microphone. And if you look at it, that these are regions of higher compression. And these are regions of lower compression. or rarefying it. And so as these compression waves move at you, a little bit of air is left behind. The air is moving. Some of the air is moving a little bit forward, and it's just like building up this compression, and then the compression lessens. And what you can do is you can plot this. If rope is being moved up and down, this is, you could say it's Y, where it's a position. If you were to plot amplitude as a function of position, what you would get is something that looks like this. That this point here would represent that point, and this point here represents that point, the gap in the middle. So if you're dealing with, now both of these can be set as air. For this, the vertical axis for amplitude would be in for pressure. And the horizontal line is your base pressure. Hold on, let me get the focus back. There we go, much better. Lock that in. All right. Oops. There we go, fine. So whereas rope waves are physically, the rope is moving up and down, what's happening in a sound wave is that the pressure is moving up or down. There's no physical displacement. It's just the quantity of a particular aspect of the air is changing. And the horizontal line is standard atmospheric pressure. Okay. Now, for the next thing is that when you're shaking this rope, and you have two fixed points, and the red line I'm just going to draw as the background line to represent no displacement for the rope. And so when you're shaking this rope, like you can either shake the rope and the other end is tied to a tree, or you could shake the rope and the other rope, the end of the rope is held on by a person. And what you notice is if you shake it, I mean, if it's just shaken at random, you just get this garbage string moving up or down. But occasionally, if you shake it at the right frequency, what happens is you get standing waves. And there will come a time where all the rope is above or all the rope is below. And it starts, there's one point in particular right in the middle that moves the most. And then the others kind of move less and less until they don't move at all. Now, the region, or more appropriately, the spot of maximum movement up and down is a node. I'm sorry, I lied. Professors do that. It's an antinode. So the antinode is right there in the middle. Now, a lot of times what I do when I'm just not feeling like drawing the line is I draw a hollow dot in the middle, and that would be an antinode when I don't feel like drawing this line. And actually, let me get these other lines ready, because we'll do them for all 5. In fact, you can sometimes use the antinode and nodes as to help you draw these. And the bottom line question is, will this be on the test? Oh yes, it will be on the test. The test, the final, labs, everything. Now, so right now you're shaking the rope, and there's one region where it is the maximum change, and then eventually it goes down to not moving at the ends, which are fixed. And then you start shaking it a little more quickly, and then what you notice is that half the rope is above and half the rope is below. And what happens then is that there are 2 regions that move the most and 3 that don't move at all. And one of those points is right in the middle. And since I didn't really say it, the points that don't move are called nodes. Okay. So here there is a one that moves the most. Here there are 2 that move the most. And you can start seeing a pattern coming along where there's none in the middle, 1 in the middle, 2 in the middle, 3 in the middle, and 4 in the middle. And so what you try to do is you just go up, come back down, go down, come back up, and then come back down. And you can get a computer to draw these, but what I'm really looking for is let me find it. I love these things. This is the template for drawing circles of varying sizes. What I want the same thing, but for waves. And I haven't found one yet. I found one that has a sample wave, but I'm looking for one with a wide variety of waves just to write it down. Because I'm old school and I like to just write it. Okay. And so you can mark the regions that move up and down. Here, there, there, and there. All right, so we have that. And now I'm going to mark this. And what you notice is you can't have two nodes sitting side by side. I'm running out of space. But you've got to have an antinode in between. You can never have two nodes side by side. And so what we're going to do now is we're going to count these things, and that you have nodes and antinodes. Let's just count them up. So here there's 2, then 3, then 4, then 5, then 6. So 1, 2. I'm already getting it wrong. It's 10:30 in the morning during a pandemic. Sue me. All right. So nodes 2, 3, 4, 5, and 6. And then the antinodes are 1, 2, 3, 4, and 5. So 1, 2, 3, 4, and 5. And the thing to remember about this is that we need to, God, there's just fluff words. Each of these waves need to be labeled. And there is a number or a quantity called N. And what you notice, this first string, the first standing wave, N is 1, then 2, then 3, then 4, then 5. So the number of antinodes equals the number of nodes. Or I'm sorry, and equal to N. And so the number of nodes is equal to N plus 1. So one of the things questions that can be asked are, if N is 3, how many antinodes are there? If N is 4, how many nodes are there? So if N is equal to 2 and N is equal to 3, there would be 3 nodes and 2 antinodes. For 3, there will be 4 nodes and 3 antinodes. There's a whole tons of questions, or there are a lot of questions that I can ask about this. Now, these N's are like the number that you reference. Like if I say N is 3, point to N is equal to 3, and then you would point to this guy. If I said N is equal to 1, point to that guy. Now, these have names. So I draw the N's, and then I'm going to draw like an itty-bitty picture of what's going on. And they'll never go, in terms of the test, they won't go beyond 5 for N. Now, there are 2 naming conventions. The first one is the harmonic naming convention. The second is the overtone convention. The harmonics go like this. First harmonic, second harmonic, and I'm going to shorten it to H. Third harmonic, fourth harmonic, fifth harmonic. For the overtones, it goes fundamental, frequency, then comes the first overtone, and then after this I'll just use O's. Second overtone, third overtone, fourth overtone. Now the harmonic is in-based. So if you have, if n is equal to 35, that's the 35th harmonic. So whatever n is, you just go, all right, n is 12. That's 12th harmonic. Done. For an overtone, it is order-based, where the fundamental frequency is always the first. The first overtone is the first standing wave above the fundamental frequency. So if I said n is equal to 3, if n is equal to 3, you are at the third harmonic, second overtone. There are 3 antinodes. And there are 4 nodes. And it is associated with that picture. So you're going to get, on the test, you'll just look at this picture. How many nodes are there? How many antinodes are there? Which harmonic is it? Which overtone is it? And this will just be all over the test. But this is the naming convention for string frequencies. And so how are these frequencies decided or determined, measured, calculated? You use this. Okay. So here are all the parts. The N is, you could say it's the harmonic number. The L is the length of string. The V is the velocity of sound in the string. And so that velocity of sound in the string is determined by 2 quantities. One, that's the tension in the string. And this is the linear mass density. And putting all this stuff together, you get You get that. And then let's talk about this with respect to a piano. So if you've ever played a piano, and I'm not talking about the uprights, I'm talking about the like the baby grands or the grand piano. You notice that the deepest part of the piano is on the left side. It has the longer strings, or cables since it's a piano. The right side has the shorter strings. The longer strings, the left side of the piano, has the lower frequencies. The right side with the shorter strings have the higher frequencies. Okay. Now, when we're talking about this, that L is big on the left side. Over here, the L is small. And when you look at this, as L increases, F decreases, because L is in the denominator. And then as L decreases, frequency increases, and it's the same thing. F is inversely proportional to L. So as L changes, F goes in the opposite direction. L goes up, frequency goes down. L goes down, frequency goes up. And it makes sense. The long strings on the piano have the lower pitch. Now, the next thing is adjusting tension. Now, if you adjust the tension on a piano, or in this case, like a guitar, if you increase the tension, does the sound of the string go, or does it go? Well, when you pluck a string and then you adjust it and tighten it, that frequency increases. So as T goes up, frequency goes up. As T goes down, frequency goes down. And you could say that F is proportional to tension. And then the last thing about the string is that you can adjust the linear mass density lambda. So the thick strings have big lambdas. The thin strings have small lambdas. And so when we look at the, let me rewrite the equation. And from here, you could see that t is in the numerator. But what we see here is that lambda is in the denominator. Okay. Lambda is in the denominator. So you can say that f is inversely proportional to t. Or actually, to lambda. So when you look on a guitar, are the thick strings lower frequency or higher frequency? The thick strings are the lower frequency. The thin strings are the higher frequency. So you can just look at a guitar, see the string, and tell if it's going to be a high pitch or a low pitch. One of the things also about tension, what does a whammy bar do on a guitar? It adjusts frequency. Oops, I don't even know what that symbol was. By changing the tension. So when you have that whammy bar and you just sit there and you just kind of like grab the whammy bar and then you just move it back and forth, what's going on with that is that it's increasing and decreasing the tension on the strings in the guitar. And so you're getting this wah, 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 wah type thing. And so that is pretty much how guitars work, pianos work, anything with a stringed instrument. Though, here's something that, physical science, you have to know, because I know it, is like you've got string instruments like violins, but technically a piano with, now if it's a electric keyboard, it's not that, but a piano is technically a percussion instrument. And why is that? Percussion instruments where something is struck. In a piano, now granted they're felt, they're very hard felt, hammers strike the string. That is how the sound is produced on a piano. You press the key, there are a whole bunch of levers and stuff, there's a little hammer and it goes bam, it just hits the string. So that's a percussion instrument. And so the bonus is I want the first person to tell me, answer the question, a piano is what type of instrument? And so for the first person to answer that, they'll get a bonus point, which will be used at a later date. So that's the question. I will have these scanned and posted I'm going to start doing modules rather than announcements. But the thing that's going to come out is on Thursday, you'll get your lab material. And you'll do that over the weekend. And then we'll keep going on. So review this, and I'll start posting between now and Thursday test 3 material. So you guys can start looking at that. And that's it. So as always, go to lab.